Our presentation on the class similarity weighted knowledge distillation for continual semantic segmentation. We start by introducing some background. Semantic segmentation is a fundamental task for many applications, self-driving car, and medical image diagnosis. The segmentation model and other general deep learning models suffer from forgetting. When learning a new class, models tend to forget what they previously learned. Compare with image classification, continual learning for semantic segmentation is still at its early stage. Recent methods apply knowledge distillation to enforce the current model to produce similar outputs to the previous model. However, they treat all classes equally and overlook the interference of visually similar classes. We hypothesize that when the model learns a new class, all classes that are visually similar to the new one will be more likely to be forgotten because the model might get confused between visually similar concepts. We measure the performance drops in each group of all classes when the model learns a new class. When the model learns a new animal shape, the performance of animal group significantly drop. When the model learns on a new class train, the performance on the vehicle group significantly drops. To address this issue, we propose to emphasize learning all classes that are more likely to be forgotten. We first use the similarity scores to identify the all classes with high similarity to a new one. Then this similarity score will be used to reweight the previous output before performing knowledge distillation. Here's the overview of our proposed framework. Reminder. There are three loss objectives. The standard cross entropy loss from the ground truth labels. The feature knowledge distillation, which penalize the changes in model's feature. And our proposed CSW KD. To compute the similarity scores, we first extract the prototype by averaging the features belonging to a particular class. Then we perform cosine similarity between prototypes of new class and the old classes. Then the similarity scores will be used to reweight the outputs. The reweighted outputs will then be distilled to the current output via our proposed CSWKD. We perform experiments on two standard benchmarks, Pascal VOC and ID20K. For Pascal VOC, we use three settings: 19.1, learn 19 classes, then 1 class. 15.5, learn 15 classes, then 5 classes. 15.1, 15 classes, then 1 class sequentially. Similarly, we have 4 settings in ID20K. And here is the result. Our reminder significantly outperformed plot on the 15.1 settings with 6 tasks. For ID20K, reminder outperforms plot on the 110 and 105 significantly. This shows that our model is more robust to forgetting on a long continual learning settings. For the qualitative result, we can see that the model, when training on block, gradually get confused between a new class ship and the dog that it previously learned before. In contrast, our reminder still retain segmentation on the dog classes. This shows that our model is more resilient to forgetting when learning visually similar classes. Besides reduced forgetting, our reminder also promotes the learning of new classes. We may evaluate the MLU on new classes. We can see that the reminder has a higher curve performance than the previous methods. To summarize, our reminder is more resilient to forgetting and promote the learning of new classes. For more details, please visit our website.